Welcome to the second part of Standard 2 of the Algebra Final Review. Told you on this one we were going to work on solving systems of equations, and in that process I was going to mainly show you the algebraic, but I do want to do a quick review of the other topics, or the other parts of this topic. Remember that we can solve an equation in several different ways. One way is by graphing it, either on a piece of paper or on a graphing calculator. When we graph two equations, or three or four for that matter, when we graph them, if they have a solution, it will be the place that they have in common. In this instance, it's where the two lines cross. If you have three lines, the solution to all three would be where all three lines cross. And we usually will find an x and a y value for that point. In tables, we're looking for the same general thing. We just don't have as good of a visual representation. In a table, we have to find where the x's match and the y's match. In other words, on this one, the x's and y's match at 4 and 10 because both of the x's are 4 and both of the y's are 10. Now, there are three ways to solve algebraically. One is to use a method called equal values. Typically, it works best when you have two equations that are solved for the same variable. Both of these, kind of written generally, are solved for y. On this one, using the substitution method, usually will work when either one of the variables is already solved for, like y is here, but not the other one, or when one of them is really easy to solve for. Elimination is often a really good method to use when you have all your variables on the same side. For example, 2x plus 3y equals 10 and 4x minus 3y equals 22. The variables are on the same side. Now we're going to focus on the algebraic methods, and so here's the three problems that we are going to work. I'm going to do them on a different sheet, but I want you to kind of visually have this moment to kind of look at how they look. Okay, both of these are solved for the same variable. Good candidate for equal values. We're going to do 5x plus 1 equals negative 3x minus 15. That's what we get to do when we have equal values. The rule says if two things are equal to the same thing, they're equal to each other. So both 5x plus 1 equals y and negative 3x minus 15 equals y. Both of these equal y, so they actually equal each other. Okay, in substitution, we're going to plug in, remember that somewhere along the road, I hope you learned that equals is often referred to as is. So I might say x is 5, or when x is 4. Here I could say y is 7x minus 5. It seems a little strange to say that, but that is another way of reading that. And when we think of that, if y is 7x minus 5, then this y will also be 7x minus 5 if it's part of this system. Okay? Or at least if we're going to be able to find a solution. Elimination usually works when both the variables, or all the variables, are on the same side. Okay, let's go ahead and look at them really quick. See if I can go through these. Okay, they are in the wrong order. So we'll get them corrected here in just one moment. Okay, now here's what we're going to do. We already showed you what we're going to do with this. We're going to say since these both equal y, we're going to set these equal to each other. So I'm going to say 5x plus 1 equals negative 3x minus 15. Now I'm just going to solve it as a regular equation. The advantage here, one of my variables is gone, makes it easier to solve for. Okay, I'm going to move my x's to the left. Don't have to, but that's very normal. Okay, that gives me 8x's on this side plus 1 equals to negative 15. Now I'm going to move my constant on this side across. Doing the opposite, that's 0. So I get 8x equals negative 16. Divide by 8. I get x equals negative 2. Now, if you were in class today, one of the things I pointed out is we have found what x is. We have found what x is, but how many variables did I start with? I actually started with two different variables, x and y. So I need to go back and find the other variable, and I do that by plugging this value in for x, because now I know x is -2. Okay, so let's plug that into the first one. Y equals 5x. That's 5 times -2 plus 1. Let's see, -10 plus 1 is -9. So y is -9. And we often will write our answer in xy form as a point. And so let's see, the x value is -2 and the y value is -9. Okay? Remember, you can pause this and rewind it if you want to look back at it. Okay, substitution. I'm going to plug this because y is 3x minus 4. That means I'm going to get to put it in here for y. So I'm going to do 2x plus 3x minus 4 equals 6. I can tell I've got a little bit of simplifying to do with these two terms. We'll simplify. Get 5x minus 4 equals 6. Add 4 to both sides. You get 5x equals 10. Divide by the number on x. I'm going to write it over here, x equals 2. Now, still only have one variable. It's always easier, almost always easier, to use this one that's already solved for the other letter, the one that you substituted in. So I'm going to do that now. Y should equal 3 times 2 minus 4. Okay, 6 minus 4. So y equals 2. Okay, so this one's, let me check it one more time. 5x minus 4 equals 6. And add 4, 10, 2. 6 minus 4 is 2. So the answer here 2, 2. Okay. Now, a little bit of time left to do the last one. And, okay, this one has a square in it, but it looks like it's going to be easier to solve this way. And so I can solve this one for y. So this is going to be a substitution one. So let's see if we solve that. Add 1. We'll get 4y equals 4. Divide by 4, divide by 4. We'll get y equals 1. Now we'll substitute that 1 in here. X squared minus 1 equals 8. X squared equals 9. Now remember, x squared equals 9 means x times itself equals 9. And we have a kind of a pattern. So this is a side note to go back. Remember that the opposite of adding is subtracting. The opposite of subtracting is adding. So when I'm solving, the opposite of multiplying is dividing. And the opposite of dividing is multiplying. The opposite of squaring a number is taking its square root. The opposite of the square root is there. Now, two numbers give us 9. The only number I can think of right now is 3 times 3. But I also want you to remember that there will be a negative of that. So 3 times 3 gives me 9, so I know that one of my x's is 3. But I can also get it by doing -3 times -3. So x also equals -3. We already know our y, so it looks like there's going to be two answers here. One of the answers is 3, 1, and the other answer is -3, 1. Okay, I think that I missed the elimination method, but I've run out of time, and so we'll do a little short video on it.